All right, so today, before we continue on with more with arrays, I wanted to take a step back and do a review. Normally, I would do this review right before the midterm, but given some struggles in the last lab, as well as the last hack, I felt it was that I was going to go ahead and move this up in order to help you with your hack this week. So what we're going to do is we're going to review everything that we've done for the last two modules. That is functions, pointers, pass by reference, and of course error handling. Error handling. There we go. Handling. There. So first of all, let's remember pointers, and we're going to do an exercise to motivate all this. But pointers. This is that thing that I tried to put up on the whiteboard at the lab that you just need to put it onto a post-it note and put it up. Or better yet, you can look for what are called cheat sheets, right? Where you've got like a calc cheat sheet with common derivatives or whatever examples that you can put up on the board and then always just look up if you forget something. You could probably find one. In fact, we searched for one yesterday in the other class. C pointers cheat sheet, right? All you need to do is search around for this if you don't want to put it on your own post-it. C for Dummies pointer cheat sheet. All right, well, that's not a cheat sheet. That's not printable. But if you search around for, say, images or something like that, then you'll be able to find something that's okay, right? I don't know how good this is, but no, that's Arduino. So you'll search around. If you find one that's good, then go ahead and post it on the Piazza for everybody else. But in any case, remember the pointers. You've got a regular old variable, right, int x. This is a regular old variable. Right. You've got int star a. I'm just using a different name here. If you want to, you can use p instead for a pointer. Is a pointer variable. Right. If you have a regular old variable, and you want to make it into a pointer so that you can pass it by reference or something like that, all you need to do is remember scanf, right? Use the referencing operator, right? That is the ampersand x, right? You would apply that to a regular old variable, in this case x. Just the opposite. If you have a pointer variable and you want to make it into a regular variable so that you can set its value, you can get its value, you can do something with it, you use the dereferencing operator. And the dereferencing operator is the star. Right? Don't ask me why they use the star when it means multiplication. Don't ask me why they use the star when it means pointer declaration. It's just the dereferencing operator. Right? I didn't write it. Right? Passing by value. Passing by value. That's what we learned first when we looked at functions. Copies, right? Copies of the variable's values are passed to the function. Any changes to those parameters do not affect the original variables, right? That's why that swap function that we tried to write didn't work. Give it A and B. Well, A and B are copies. They're in their their own function stack frame, right? They're completely different copies here. Okay. Pass by reference is just the opposite, right? You pass pointers or memory locations are passed to the function. Any changes via the pointers do affect the original variables. Right? That was the second version of the swap function that we wrote. And it was successful in changing things. What are the use cases here, right? Use cases, right? Cases, there we go. You can return multiple values, right? Just like you did in your lab. Instead of having to write 3 different functions for sepia, one for the red, one for the green, one for the blue, you only have to write one function. And you pass in 3 variables, RGB values, pointers, in order to change them. Right? You can directly change the original pixel values. That's why you don't need 3 functions for the black and white. You can pass in variables passed by reference, and you can change them, right? The first version, Lab 5, we were forced, because we weren't using a pass by reference yet, we were forced to write so many functions, right? And also, it frees up the return value for error handling. Right? Handling. Now, original. Right? Now, instead of dying, instead of printing something out, which you don't do either one of those things, you can go ahead and return an error code. By convention, remember, 0 is no error, 1, 2, 3, those are different types of errors. And that always needs to happen first, right? Error handling, sorry. It is a look before you leap, all right? That means that error handling in a function is the absolute first thing you do. Oops. Freeze, you do. There we go. There. That is the very, very first thing you do in your function, right? You do not leap before you look. If you try to dereference a variable without first checking that it's null, you're going to have a bad time, right? That's Bret Hart hitting you upside the head. You dereferenced a null pointer, resulting in a segmentation fault. So, null pointer checks come first. Right? They are the first of the first. If you have any values that are being passed by reference, you need to make sure that they're not at least null first before you can use them. You do not print anything. Right? You do not exit the program. We were doing that kind of stuff in the main, and it's still fine to do that in the main, but now we are writing functions. Square root of a -1, that doesn't quit out of the program. It doesn't print anything, right? Instead, it communicates some sort of an error code. We saw how POSIX systems do that. We're doing it differently, though. We are returning an error code value. An error code, instead, what you do, you return an error code, right? An integer. 0 for no error. Non-zero for some type of error. And you can either use defines or you can use an enumerated type. You can use an enumerated type to use human readable words for error codes. Right? So after that review, let's do an exercise here. Right? We're going to do everything that we basically did on Lab 6, right? But in a different context here. We're going to do some weight conversions. So weight, we did distance in the very first week, right? Kilometers per hour, or kilometers 2 miles or something like that. We're going to do weight. Weight is different from mass, right? If you're out in space, there is no weight, but you still have mass, right? Weight is the mass in presence of gravity. It just so happens that our usual units for measurements are with respect to Earth's gravity, right? For example, kilogram force. It's the same thing as kilogram in 1G, right? Now, you might have the same mass. You go on the moon. You have the same kilograms, but you have different kilogram force. You don't weigh as much on the moon. Pounds and ounces and newtons are other ways of measuring weight here on Earth. Between these scales, you can convert them. 1 kilogram is about 2.2 pounds. There are 16 ounces in a pound, pints a pound the world around, right? And there's 1 kilogram force is equal to 9.8 newtons. Does anybody know? What are newtons anyway? What is 9.8? What's the relationship to anything else that you know? Acceleration, right? That's gravity right there, right? That's how newtons are defined, right? Okay. So what we're going to do is we could write a collection of functions to convert between any 3 of these, right? Actually, 4, sorry. If I wanted to write functions to convert from any one of these 4 to any other of these 4, how many would I have to write? At least 12, right? I don't want to have to do that. What I want to do is I want to write one function that takes, say, kilogram force and converts it to pounds, ounces, and newtons all at the same time, okay? By the way, in real life, would you do something like this? maybe kilograms and newtons, but should you be playing around with pounds and ounces for any scientific stuff, any real stuff, right? Consumer-facing stuff, yeah. Your grocery store app needs to tell them, yes, you are buying 4 ounces of this thing, but whatever, right? If it's a real scientific application, you stay in metric, period. Right? Scientific units, right? Okay. So what the first thing I'm going to do is I'm just in this directory here so that I can post the code later. Let's go ahead and create a new, I don't know, weight.h file here, right? And a new weight.c file. Tell me what those files are. .h stands for what? What does the H stand for? That's a header file. What belongs in a header? Prototypes and documentation. So let's go ahead and create this prototype. I don't know, weight, convert weight. There we go. What ends the prototype? The semicolon. So let's go ahead and document this. What I want to do is converts the given kilogram force, right? Kilogram force, converts it into the other 3 units. And I'll just put that in parentheses here: pounds, ounces, and newtons, right? Newtons. There we go. Right. And also, it's going to eventually return an error code, right? Returns a non-zero error code if for any error conditions. Right? We'll come back and maybe update that documentation to say exactly what kind of error conditions there are. Right? Maybe, maybe not. There's my documentation. I need to complete my prototype here. So first of all, what is the return type going to be if I'm going to be returning an error code? An integer for now. Later on, we'll come back and put in an enumerated type for that instead. Okay? Convert weight. Well, if you're going to take as input here kilograms force, right, that's going to be a double. Now, do we make this by reference or by value? I'm taking one value and converting it into 3 other values. Does this need to be a pointer? It doesn't need to be. I'll leave it like this. I want to convert that into the other 3. Double pounds, double ounces, double newtons. There we go. Am I going to be able to set those 3 values in the function? Sure, but is that going to change anything from the calling function? Nope, because these are all passed by value. I want to pass in buckets, 3 buckets that you can fill with values, right? So that we're sharing these buckets. I know where they are. The buckets are memory locations. So I need to change these into pointers. How do I do that? Star, star, star. Right? Those are all now passed by reference. Using the pass by reference variables. There we go. Good. You can abbreviate pounds, LBS, if you want. You can go ahead and write this out, kilogram force. Right? That's probably better because it's consistent with the rest of them. If you want to use KGF on this one, then use LBS on this one, OZ on this one, newtons. That would just be N, but that's too short, right? So I'm going to go ahead and go with this. Okay. All right. Weight.c is a source file, right? That's what we mean by a source file. A header file contains documentation and prototypes. What does a source file contain with the same name? The actual definition of the function. What should we do first, though? Include stuff, right? Include any headers. Automatically, you should just include the standard library, period, right? What else should I include? Well, I need to include the header file that defines the prototypes for the functions that I'm actually writing here. Include unit weight.h. Right, there we go. Is it correct to include weight.c? No, at no point have we ever had an example that was where you include a header file. Let me show you what happens. I thought I showed this at one point, but maybe not. Let's go ahead and compile wait.c. There we go. What's going on? It's an infinite loop until it died, finally. It overflowed its own stack. The compiler overflowed its own stack. The compiler is a program. It has a stack frame too. It has a call stack as well, and we just overflowed it. Why? Because I was including this file right here. Well, what's in this file? I am that file. So what happens is this thing gets replaced with the contents of that file. Well, guess what? That thing gets replaced with the contents of that file. That thing gets replaced with the contents of that file, etc., 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 etc. That's why it's stuck in an infinite loop. You never, ever, ever, at least as far as this class is concerned, include source files. So tips. You never, ever include source files. Right? Do not do that. Right? It will not compile. I compiled on my machine. Yes, that's because you compiled it incorrectly. 2 wrongs made a right just by coincidence. Right? So don't do that. Right? Okay. Convert wait. Help me out. What's the first thing I do in a function? Start writing code, mashing the keyboard. No. What's the first thing you do, period? Error checking. Right? What's the first thing I do when I'm error checking? Check for null pointers. What could be null? Pounds, ounces, newtons. Could kilogram force be null? No. Why? Is it a pointer? No, it's a regular old variable, right? It's not pointing to anything. It's not even a pointer, right? So I check for null pointers. If pounds is null, null. Or if ounces is null. Or if newtons is null. Correct. I mean, well, we'll get to that here in a second, right? So if any of those are null, what should I return? Should I return 0? 0 indicates no error. This is an error. You gave me null pointers. I'm not going to dereference those. Otherwise, Bret Hart will show up, right? So I return, well, 1. We'll start there. Right? We'll fix that later. Is this correct? Dereference pounds and ask if that's null. Nope. If you have a pointer variable and you want to make it into a regular variable, you dereference it. That's what I'm doing right here. Right? Is a regular old variable a pointer? No. So you can't compare it to a null. Right? So no, you do not dereference these things. You check to see if they're pointing to null. Now go to your now as to your question. Well, what about that kilogram force? What is something that would be bad input as far as kilogram force is concerned? Okay, negative. Can you weigh negative 10 pounds? Now you can strap balloons to yourself and rise above the atmosphere. That's buoyancy. That's not weight, right? You still weigh. You still have gravity and mass pushing down on you. It's just relative to the ground. Relative to our atmosphere, you have buoyancy going up. Right? Else if kilogram force is less than 0, you might think that, well, maybe 0 is a bad value too. I don't know. If it's only way that you would have 0 weight is if you have 0 mass as well, right? And then you're talking about nothing. I don't know. Maybe you want to treat that as an error. I don't know. That's when you go back to the designer and say, can you have 0 kilogram force or not, right? Why did I return 2? That's a different type of error, right? If you want to be able to distinguish between the types of errors, you need to return different type error code values. If you wanted to split this first check up into 3 different checks, the first parameter gave me something bad. The second parameter gave me something bad. Or the third parameter gave me something bad, right? If you wanted to make that kind of fine-grained design, that's fine too. I'm not going to go that far though. I am not done error checking. Right? Before I start the actual code, don't forget the other type of error, no error. What should I return at the very end here? 0 to indicate that there's no error. Okay. Now that I am done with error handling, unless somebody else can suggest anything else that could go wrong there, do I need to check that, okay, well, pounds is not null, so I could check to see what's inside that variable already. Right? Is that relevant, though? I'm going to convert from kilogram force to the other 3. I'm going to overwrite those variables no matter what. Do I need to worry about what's stored in there already? No. Okay. All right, so pounds. Remember how many pounds there were? What was it? 2.20462 is equal to 2.20462 times kilogram force. There we go. Yeah, is that correct? Well, as in, like, I have to write it like this? No, that's just fine. But as in opposite of what's wrong with the left-hand side. Yeah. Oh, thank you. I misspelled force too. There we go. What about that left-hand side? What's on the right-hand side here? It's just a number, right? What's on the left-hand side here? A memory address, a pointer. When we have a pointer and you want to make it into a regular old variable so that you can set its value, you do what? Dereference star. Right? Likewise, let's see, ounces is equal to this entire thing again, but 16 ounces in a pound, right? So you could do something like this. You could pull out your calculator and just do 2.2 times 16 and put that in as a value. The compiler will do that for you, though, right? Another thing that you could do is say, well, okay, well, that's 16 times pounds. Right? Is that the correct way of doing it, though? Remember, pounds is a pointer. If you've got a pointer and you want to change it into a regular old variable so you can use its value, what do you need to do? Dereference it. Right? Does that... Ugh, that looks kind of ugly, though, right? This conflates multiplication and the dereferencing pointer. It will work. It will do exactly what I just said that it would do. But it looks kind of bad, right? Because white space doesn't matter. What does it look like now? 16 raised to the power of pounds? Yeah. Avoid that. Yeah.
I think you have to actually divide by 2.2.
Oh, divide by 2.2? Yeah. Is it? Kilogram force. Is it? 1 pound to kilogram. Oh, you're right. Yeah. Okay. Sorry.
Oh, no, you're all good. I was in there.
Wait. Is it? No, you've confused me.
Run it and find out.
No, this is right. This is right. I just confused myself. So, right? Because kilograms are heavier than pounds, right? If you bench 100 kilos, you're hitting that 220 mark, right? Exactly. You don't use the imperial system anyway. Period. Right? Okay. Anyway, does that look nice? No. Generally, what the tip that I'm going to give you is generally you should avoid dereferencing too much. Right? It's not an efficiency issue. It's more of a style issue. Right? For example, I saw a lot of people get into trouble by setting their RGB values by dereferencing and then trying to reuse them again. You set the red value, you've already overwritten it. You can't use it again with anybody else. So generally, you should avoid dereferencing too much. In other words, if you want to set a value, reference it once at the end of the function. Right? Use temporary variables instead. Then you won't confuse yourself too much. That's the pattern that we followed when we did the loan function, right? We computed the monthly interest rate or the monthly payment. Well, I used a local variable to compute the result, and I used that all over the place. And then only at the end did I actually set it once. Okay. All right. So, what should this look like instead? Probably something like this. Times 16. Right. Oops. There. And finally, newtons is equal to, what was it? Kilogram force times 9.80665. Right, there we go. I like that. Note here that I kind of aligned all my equals. Right? I forget what that was. There's a name for this, but I forget what it is off the top of my head. Where you align all the equal signs so that it looks nice, right? That's not necessary, but it does look better than, say, like if you did something like this, it's all over the place or something, right? So undo, undo, undo. Coding, aligning equals signs style. What is it called? Lining up similar lines, okay. Aligning equal signs for continuing an occasion. Well, I have vertically aligned my code, and you should too. I don't know. There's a name for this. Does anybody know what it is? Kernel style? I don't think so. Okay. There should be a name for it, but I forget what it is off the top of my head. Anyway, this function looks like it's pretty much done. Okay? So I've got this and I've got this. Tell me, how do I properly compile this now? How do I have a main, by the way? Nope. If I were just to compile this with just regular GCC, wait.c, what's it going to complain about? Undefined reference to main. Well, yeah, I didn't write one. Right? This is a library. There's no main in the math library. There's no main in the standard library. Right? Main is for programs that you want to actually compile into an executable program. Right? I don't want to compile this into an executable program. It's just one function. Right? So how do I compile it without a main? What's that flag again? -C. That will produce a .o file over here, an object file. Before I go on, though, what else should I have compiled it with? The wall flag to see if anything's wrong. If I want to use valgrind in order to see if that null pointer segmentation fault or something, what line did that happen on? What other flag should I use? -G. Right? There we go. Whether or not we end up using valgrind, probably not, because I think that this code is fine. Right? That does not provide an executable file. There were no warnings, by the way. Great. We're good to go. What you need to do is you need to create either a main tester or a main driver, depending on what you want to do. We did both for you in your lab the last 2 weeks, right? We gave you an image driver that had a bunch of other stuff to combine so that it would load up a file, load up an image, regardless of the format, apply your filters so that it was sepia tone, and output it to a new file so that you had that new image. That was a driver program, right? That was basically the application that you could use to test it. What we gave you this week or the last week and this week, I guess, were ad hoc, informal unit testing framework and a formal unit testing framework, CMACA this week, right? Those are the tester files. So let's go ahead and create a tester file here. New file. Wait test. Wait utils test or whatever. Tester.c. Okay? That is where you place your main. Int main, int argc, char argv. There we go. Return 0. And what else belongs up here? Author, date, blah, blah, blah. Include standard library. I'm going to probably do some input and output. So I'm going to have to include the standard input-output library. I'm probably going to do some math here, and I'll show you why in a second. What else should I be including? If you want to use wait stuff, wait.h, include wait.c. Is that correct? Nope. Always, always, always header files. Only ever header files. Okay? All right, let's test the wait conversion. To test, you need input, you need expected output, and you need the actual output so that you can compare them to the expected output and see if it was correct. So let's put those in. Right? Let's go ahead and say that we've got double kilograms force 100 kilograms, let's say. Right? And double expected pounds expected, well, what would that be, by the way? If you've got 100 kilograms, expected pounds would be, you pull out your calculator, you pull out something else entirely, and that would be 220, this is just my head now, 462, right? Double expected ounces. Help me. Times 16. There's my calculator. Come on. Come on, why? Whoa, it won't let me click that? Plain text. Fine. There. There's my expected ounces. Double expected newtons. That's going to be 100 times 9.80665. That's why I chose 100. Right? That's a good test case because I could do most of the calculations in my head simply by moving the decimal point over. Okay? Double actual pounds. Can I set that to anything yet? No, that's what the function sets. Actual pounds, actual ounces, actual newtons. There we go. Now, in case you think that I will admit that there's a weird use of terms here, right? The actual pounds. That would tell me that it should be the actual value, right? No, it's actual with respect to the function. That's the actual value you get back from the function. Of course, 220 is the actual value that we expect, but that's what we expect, not what we actually get from the function necessarily. Okay? And then maybe I need an error code, right? Error code, right? Because it's not a double, is it? It's an integer. And now I'm going to actually call this function, which was convert weight. I need to pass in the input, kilograms force. It's a regular old variable. It expects a regular old variable, so you use it as a regular old variable. But what about the actual pounds, actual ounces, and actual newtons? Do I pass them into the function like that? Nope. These are regular variables. The function expects pointers. Right? So, okay, well, I'll declare them as pointers instead. Pointer, pointer, pointer. That'll work. That'll compile. It won't complain about it, but yeah, they're null. What are they pointing to right now? They're uninitialized pointers. Likely they're pointing to null, but they could be pointing to garbage. They could be pointing to memory location 42 that doesn't belong to me. Right? That's not the way to go about doing that. Right? Instead, I want to take this regular old variable and make it into a pointer using the referencing operator. Right? So, ampersand, 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 just like scanf. Okay? I don't know, has anybody found a nice C cheat sheet? Not Arduino. Is this nice? That's the one we were looking at yesterday, but it's kind of crappy, low res. Yeah. I'm not going to use Google. Okay, no, stay away. That's C++. Right. All right. Anyway, now I need to actually check for this. First of all, do I get the correct error code back? Should this have resulted in any errors? Probably not. So if my error code is not equal to 0, then this fails. Printf fail. Whatever. Right. Else if maybe the actual pounds failed. If the actual pounds is not equal to the expected pounds, then it failed. Printf fail. Now this is why we gave you Lab 5, so that you would have a framework from which to work off of, so that you could report a summary report. You would increment counters for the number failed, the number passed. You get this nice little report down at the bottom, right? And I'm not going to do the rest of this here, but I will draw your attention to this check right here. The check on line 16 for an error code being 0, that's clear because an integer is an integer is an integer. Right? 2 is not equal to 4. 2 is equal to 2, period. But what about floating point numbers? Are these necessarily going to be equal? Even if they're, 1/3 versus 0.33333333334. Are those the same thing? They're pretty darn close, right? So how do we test for failure or success with respect to floating point numbers? If it's close enough, right? We gave you that function and we'd hoped that you'd use it, right? But many people didn't. Instead, they did abs and the difference between it, which is what was in that function, except that there's an error there. What is abs good for? Integers. These are not integers. What do you use instead? Fabs. That's what we used in the function. We'd hope that you just used the function. And by the way, just in case people were apprehensive about using what we gave them, right? Please do review the code usage policy for this course. Documents, code usage guidelines. Basically, don't post any code in a public message on Piazza. It's required collaboration in that we will team you up if you don't already have a team. Hacks are this is what I want to look at. The following instances are examples of code usage that are acceptable. Any of the following pieces of code may be used in your labs, hacks, assignments, and exams. Exams. Any function provided as part of the language standard library. It is never cheating to use that built-in function, right? How the hell are you going to print stuff if you're not allowed to use printf, right? Any piece of code that was provided to you by the instructor, right? You're not cheating off of me. I gave it to you for a reason. I wanted you to use it, right? Any piece of code that you wrote as part of a lab, hack session, or from another assignment. So you'll find that a lot of the assignments build on each other. You could use, like, for example, air distance, right? We're going to give that one to you again, third time. We don't want you to, have to reinvent the wheel every single time. Take that code, modify it if it needs to be modified, but otherwise use it. Any piece of, if you have a piece of code that you wrote on a hack and you want to use that during an exam, that's perfectly fine. It doesn't matter if you teamed up with somebody else. It was still a product of your own mind along with that collaboration. Right? Any piece of code that you wrote outside of class. So if you've got a, I don't know, are many people taking that, what's the EE course? Is it 102? ELEC 102? Are you doing any, like, Arduino stuff right now? I thought you were. Next semester. Okay, so you're not doing any C in any other courses right now. Okay, so suppose that you were. Suppose that you were playing around with a bunch of Arduinos in ELEC 123, right? And you wrote this really cool function for doing some really cool thing. Go ahead, use it. It's yours, right? In fact, not here on this campus, but at UNL, a colleague contacted me and said, I think I have an academic integrity case. These two individuals, they have this exact same function, and they claim that they didn't work together. They just claimed that they took your class. And I looked at it. Yep, that's the function. All right, I gave it to them. Oh, okay, well then that's not academic integrity violation, right? So if you wrote it for another class, it's a product of your own intellectual property. It is your intellectual property. You can use it, right? Now, this may change in another class. So don't quote my acceptable code use guidelines in another class, because that ain't going to fly, right? What's unacceptable? Any piece of code copied from another student in any form without attribution in a situation where you're not allowed to do that. Here, it's just going to be exams. As far as hacks go, if you are teamed up with somebody, that's perfectly fine. In fact, we want you to turn in the same one. We keep seeing hacks that claim to have two authors and only one name on it, right? Both of the names belong on there, right? Don't cut and paste from another student outside that hack pair, right? So the point of limiting it to pairs, by the way, is 3 is a crowd, 4 is unreasonable, 5, 6, 7, that's cheating, right? It's cheating in that there's such a diffusion of responsibility that there's no way that all 7 of you are learning and learning the same amount, right? So stay within your hack pair. Providing another code to another student or allowing another student to copy your code without taking reasonable means to prevent another student from gaining access to your code. In other words, I'm not going to share my code, but I am going to go ahead and go downstairs and get a coffee. All right, I'll leave my computer open, right? Knowing that somebody is going to have access to it. That's not allowed. What is, if you're the victim, right? They guess your password or something while you're at another class, and they hack it. They gain access to your computer without reasonable means, right? That's not your fault. Okay. Maybe making your code publicly accessible prior to final grades posting, right? In other words, posting it to Piazza, posting it on a public GitHub forum, right? After this course is over, I don't care, right? Lots of people even ask me, can I go ahead and post it because I want a GitHub presence for jobs? I go, well, yep, that's fine, but quickly find something else because that's not sufficient for job hunting, right? Accessing websites like, we know all the cheating websites, Chegg, Course Hero, Freelancer, et cetera, et cetera. Asking somebody to do your work for you is definitely not okay. Yeah.
After the turning date, then can we compare code with each
Oh,
other?
yeah. Absolutely. Right? Just not before the due date, unless you're with a hack pair, and definitely not an exam, even if you're a hack pair. Right? By the way, I mean, stay away. I mean, there are legitimate uses for Chegg if you really are, not really, but they're trying to legitimize themselves. Over the last year or two, Chegg was bought out by another company, parent company, and they're trying to be better about it. And the way that they're trying to be better about it is, if an instructor sees something on Chegg that's clear academic integrity violation, and I've done this. It's a huge pain in the ass, but I have to do it. I put in a request, a DRM, Digital Millennium Copyrights Act, DMCA request to take it down. They give me all the data. They give me every single person who posted it, every single person who ever accessed it, and all their information and exactly when they did it. Right? That is a silver bullet to an academic integrity committee. Right? I don't know what the policies here are at UNO. You're in a different department than I am. Most of you are in the ECE department, so I don't know what their policy is on academic integrity. I would probably just give it to them and let them handle it. All right. So keep that in mind. Don't be stupid. I can Google search for the Chegg too, right? And I do, and I always see my stuff up there, right? So don't do it, right? If you're doing it, then you can be damn sure that other people are doing it, and they're getting access to the same copied code, right? Your probability of getting hit by moss just increased exponentially, right? Because you're copying from the same place, right? Don't undermine the learning experience of others. If somebody's willing to share something with you, then it's likely that they've shared it with others. All right, and now you've got 2, 3, 4 copies out there. It is super, super easy to find this stuff. I'll also share, do I have, not this, but I don't know if I put it into this document, but 1 year, maybe 5 years ago, somebody was caught, using one of these websites. And the way that they were caught is that they were blackmailed. So when you go onto one of these sites and you solicit somebody to do your homework, right, and you end up paying them, right, that's not necessarily their main source of income. They'll come back to you and say, all right, now pay me double for not telling your instructor about it. Right? That's what happened in this case. Right? That was several years ago. They didn't pay, or they couldn't pay, or they didn't believe the guy, and so they notified me with all the evidence immediately, and they were busted. Right? I have no idea what happened to them, but they definitely did not take that course ever again. Right? So keep that in mind. Right? You're not just playing with your own academic career here. You're playing with blackmail. The kind of person that would go onto one of these sites and cheat for money. It's also the kind of person that would openly blackmail somebody, right? They don't have any scruples. They don't have any ethics, right? So don't trust them, right? All right, sorry to have to give that, but let's go back to the actual code here. Any questions on this so far? Otherwise, I think it all compiles well. GCC, wall. I'm using math, so I have to use -lm. weight.o, and what was this called? Weight tester.c, and I'm using the math library. Oops. Well, that's just warnings. Ooh, error code. Error code, undeclared. Oh, I misspelled it. Error code there. I guess the last thing that we could do is, instead of using these error codes over here, I should define an enumerated type. Right? So type def enum. What should I call my error codes? No. Oh, okay, good. Why do I start with no error? Because it starts counting at 0. Null pointer error, I think, was the other one. And then finally, what? Negative value error. There we go. And I need to give this a name. Error code. Right, there we go. Semicolon. And you can, if you want to, change the return value here. It's not going to make any difference. It's just an alias at that point, right? But if you do change it one place, you have to change it in a couple places. And you should start using these values instead, right? If it's a null pointer error, or if it's an invalid or negative value error, or in the event of 0, it's no error. There. I'll make sure that you have all that in the repository here. Any questions on anything that we just reviewed at all? Yeah, go ahead. No? Oh, yeah, go ahead.
If you make a, like, so far we've made like a function, we made like 3 functions, and then we combined it into 1 function with pointers. Once it gets through the compiler, does the program run better if it's using pointers?
It's a good question. It's not really running better. It's just that's the style of C. If anybody has a Python background, or if you eventually learn Python, every programming language has its own way of doing, a preferred way of doing things. And in Python, they call it the Pythonic way. So this is the C way, right? Most stuff should be passed by reference. Because dealing directly with memory means that you're not copying stuff on the call stack. You are copying the references onto the call stack, but at the end of the day, it's not going to matter that much. When it starts to matter is what we're looking at right now, arrays. How would you take an array that's 20 million integers, right? So 80 megs. Are you going to copy all of that and hand it off to a function? Probably not. That's 80 megs that you're copying and then cleaning up just to call a function, right? Instead, you say, there's the array over there. I'm not going to copy it. You can jump over there and start playing around with it. And that's passed by reference. That's the whole purpose, like another use case for it. The vast majority of programming languages are like that. The one exception that I can think of off the top of my head is PHP. It is arrays are passed by value, and that is quite inefficient. So you can change it, but the default is to pass by value. You would not want to. You couldn't, right? If you had 80 megs that you needed to copy onto the program stack, we've already seen the consequence of that, right? Stack Overflow. So you can't do that. You have to pass certain things by reference. Right? So it's not a matter of is it more efficient, it's a matter of it ain't gonna work otherwise. Right? Yeah, question? No?
Yeah, it's not really about like the code specifically, but in like the .h and .c files you made, what's your like top of page documentation supposed to be?
That's a good question. Note, now that we are in multiple files, at least one needs author documentation. You don't have to write author documentation for every single file, although if you can, if you write it for one, it's less than 2 seconds to copy paste, right? Typically in real life, what will happen is that you annotate it instead with, say, something like this. Let's say something like this. At copyright version 1.2. Right? And now what's going to happen is, as another program, you run another program that comes in, looks for that annotation, and then cuts and pastes whatever your current copyright notice is, so that if you ever change it, you don't have to go to 50 different locations and change it, change every single copyright notice. You have, nope, update it to version 3 here, and then it cuts and pastes it in for you. Right? You'll see all that all over the place, like even here maybe. Hey, there. You think somebody went in there and wrote that every single time? No, it was auto-generated at some point, right? Copyright to the current year. They probably didn't even generate that year. That was probably a program that said, what year is it? It's 2022. Okay, I'll go ahead and put that in there. Right? And then this is a, let's see, it's a GNU tool. It's a free software foundation. So it's a GNU license. I don't know what exact license it is. There we go. Okay, there we go. Lesser GPL. It's a GPL license, general public license. So it's just saying this kind of copyright notice is saying it's copywritten. You can use it. You can do whatever you want with it. But if you use it, you can't sue us. If you use it and it breaks and costs you money, you can't sue us. Right? That's the kind of general license that is. I am not a lawyer. All right. Any questions on any of that other stuff? All right. Then we don't have a lot of time to go back to the functions. So what I want to do is at least show you one other thing to finish out the week on arrays. I don't know. Let's say using arrays and functions. Often you need to pass an array to a function, right? So that you can do stuff with it, right? For example, you can pass an array of weights to a function to sum them up, right? That's a pretty straightforward kind of function. Here's an array of things. For example, here's an array of, or here, let's go double, weights, right? I don't know. If this is pounds, 42.5 pounds and 98.61 pounds, and mash the keyboard dot 23 pounds and that and dot 45 pounds, right? There we go. Right. There's an array of 1, 2, 3, 4, 5 elements. Let's keep track of that in a variable here. Okay. I want to sum those up. So how would I go about doing that right here in this piece of code? Just a regular old for loop, right? For int I equals 0, I is less than question mark, I plus plus. Remember, I is an index variable. You want weights of I, right? And you want to add that to a running total, double total. Total plus equals weights of I, right? Two problems here. One obvious problem and maybe one not so obvious problem. The obvious problem is that I've got question marks here. What do I do? There's 1, 2, 3, 4, 5 things in there, right? So I could put in 5, but I shouldn't. I should put in what? Oh, 4? Careful. If I want to go less than or equal to 4, yes, I agree. 0, 1, 2, 3, 4. I want to include the last one there. Right? But usually the idiomatic for loop here is strictly less than the size of the array, 5. But I put that into a variable for a reason. Right? Let's use that variable, n. Okay. Generally, n is used for the size of an array. If you have 2 arrays, you use m for the second one. L, M, N. No, then that's it. You don't use O. That's weird. Right? If you used O, what's the problem there? It looks like 0, right? O, 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 right? Especially if you're using a weird kind of font for your coding, right? Always use monotyped serif fonts for coding environments. The second issue, what is it? Anybody see it? Hint, line 27. It's not initialized, and so it could have garbage values. Garbage plus 42.5 is garbage. Right? Initialize your values. Right? Let's go ahead and compile this and show you that it actually works. Right? There we go. Total is equal to 0? Uh-oh. What's the other issue? Total. That would have come up here with my warning flags right here, line 31. Don't ignore warnings. If you're not compiling with the WL flag, we certainly are on the grader. Right? And pay attention to all the warnings that show up on the grader. Okay. GCC, there we go. And A dot out. There. Somebody can verify if that's correct or not. I don't know. Pull out your calculator, right? But what I wanted to show you is you could put this into a function, right? Let's go ahead and go over here to our weight.h, and let's go ahead and create a function. It takes sums up the given values in the given array of double values. Sums up the values in the given array of double values. There we go. So what should I call this function, first of all? What does it do? Get some array, right? Something like that. Okay, I like get some. Right? There we go. What's the return type here if I'm going to be taking in an array of doubles? Double. Okay. And how do I take in an array of doubles? Well, is this my array? How many values is that? 1. So how do I refer to an array of things? How did we do it when we created dynamic memory? Well, we'll certainly need n here shortly, but what else? A pointer. We take it by reference. Over there, there's the array, right? I'll go ahead and shorten this to ARR. R. We'll come back to this, okay? Because we're not done there over there yet. All right, I'm going to steal my code from over here. Come on, there we go. And instead of printing out the result, I return the result. Return total. There we go. Now, is this going to compile? Compile weight.c. Nope. Well, first of all, I've got a couple names wrong here. It's no longer just weights. It is ARR. Okay. But what else is wrong here? What's missing? N. Okay. Int n is equal to the number of elements in the array. That's what I want it to be. Is there any way to tell that from the information that I have here? No. And do not read the damn blog posts or Stack Overflow posts that say otherwise. If you have a dynamically allocated array, there is no way to determine the size of the array just given the pointer. Unless you go in and start doing system level programming and reprogramming, you will never have that information, period. There is no way to tell that. Okay? Do not think that you can use size of array. That doesn't work. That tells you the size. What is array? It's a double pointer. That tells you the number of bytes that a double pointer takes in the system, right? Which is only going to be 8. Right? That's not correct. Size of array times number of elements. No, doesn't work. Instead, what do you have to do? You have to tell the function int n. If you have an array that you pass to a function, you also have to do your own bookkeeping. You must tell the function how many elements are in that array. Every time. Anytime you have an array as input, you have to tell how big that array is. That's the only way that it can work. Right? Do not read crappy blog posts or Stack Overflow answers that say otherwise. It is not true. Right? Or if it is true, it's they're talking about static arrays, and we're not going to use static arrays much longer. Right? Compile that, and let's use it instead of using this over here. I've got my weights. I've got my array. I've got my size. Let's call that some. What do we say? Get some. Right? And we'll pass in the weights. We'll pass in the n. Okay. Be careful here. Go back to your checklist. This is a regular old variable. This is a pointer variable. If you have a regular old variable and you need to pass it by reference, it's going to be ampersand. If you have a pointer variable and you want to make it into a regular variable, you dereference it. Keeping that in mind, am I calling this function correctly? Don't worry about the n. That is passed by value. Right? That's perfectly fine. But what does the first one expect? An address, a pointer. So we need to give it a pointer. Okay. That's exactly how you do it for arrays. Right? An array name is already a pointer. You do not need to pass it by reference here because it's already a reference. We'll understand that next week when I show you how this is actually done under the hood in C. This is a pointer, and weights of 0 points to the first memory location of the first guy. Weights of 1 is pointer arithmetic that points to the second element of the array. Then 2, 3, that's why indexing is 0, because where does it all start? Over here with no offset. We'll look at that in detail on Tuesday. But otherwise, this should work. Let's go ahead and compile everything, just unused stuff, and I get the same answer as before. When you use arrays with functions, you have to pass in a pointer. You have to pass in a value. Be careful, though, and this is where we'll pick it up on Tuesday. What if I also, I don't know, screw it up? Array of I is equal to -1. So I'll go ahead and add everything up for you, but I'm also going to mess up your stuff, right? I'm going to mess up your array. Does it seem like we should be able to do that? It'll compile. It'll run. Just fine. But if we do it a second time, guess what the weights are now? Yeah, they're all -1s, and there are 5 of them, so the sum would be -5. Doesn't seem like we should be allowed to do that, right? Here you go. Now I'm the person that's giving you. You're the function. You're the getSum function. Go ahead and sum these guys up for me, please. Okay. Also screw it up while I'm at it. Does that sound like a good thing to do? Probably not. I want to prevent this function from changing those values. Right? I want to make it into a constant. Right? You're not allowed to change those. We've seen that before, right? Int foo is equal to 42. Once you've created an integer and made it constant and set it equal to 42, can you ever change it? Nope. This function is not allowed to change this array anymore. And so when I try to compile it, it says, nope, you can't do that. It's a read-only location for that array. You're attempting to change it to -1. Do not do that. Once I do that, then the compiler is perfectly happy with that. Oops, that's not what I wanted in terminal. There we go. Now it compiles again. Oh, and then I need to change it over here too, right? I need to change this and do const. Okay. We'll pick it up there and review that on Tuesday, though. I'll see you over in your lab.